What if the rock in your hand isn't just a rock? Every year, people walk past stones like these, metallic, dull, or crystal clear, never realizing what they might be holding. Some look like ordinary river rocks. Others shine like raw crystal, but both can hide something incredibly rare beneath the surface. In this video, you'll see two real stones that fooled almost everyone at first glance, until a simple observation revealed what was really inside. Don't blink, because once you learn what to look for, you'll never see rocks the same way again. If you see this shine on a rock, stop. That's real silver. What most people walk past every single day could actually be one of Earth's most valuable natural metals, hidden in plain sight, wrapped inside the dull, gray skin of ordinary stones. Silver doesn't always appear in shiny coins or jewelry. It begins its story deep underground, forged in heat and pressure, waiting to be revealed by the right eyes. When sunlight hits certain rocks, you might notice a faint metallic gleam. Not the sparkle of quartz, not the flash of mica, but something heavier, smoother, more persistent. That subtle glow is nature's quiet signal, a sign that native silver or silver-bearing minerals could be right beneath the surface. These are the moments gem hunters and mineral prospectors live for, because unlike gemstones, silver hides with intention. It doesn't shout for attention. It whispers through texture, luster, and pattern. To understand what you're really seeing, you first need to recognize the rocks that hold silver. Most often, it's found in host stones like andesite, basalt, or other dark volcanic rocks that have been penetrated by mineral-rich fluids over millions of years. These fluids carried silver, mixed with elements like sulfur, arsenic, or antimony, and cooled slowly inside cracks and veins. Over time, they formed minerals like argentite, chlorargyrite, or galena, all of which contain silver in different concentrations. Look for streaks that appear grayish-black or thin metallic films that catch the light differently from surrounding rock. If the shine stays steady when you tilt it in the sun, rather than flickering like mica, you may be looking at something that deserves a closer inspection. Silver-bearing rocks tend to have a greasy or dull metallic sheen, and sometimes you'll see small cubic patterns, signs of galena crystals, which often host native silver alongside lead. You can also spot silver in oxidized zones, where the surface of the rock appears crusted or tarnished with subtle hues. A faint blue-gray, sometimes yellowish-brown, sometimes even a dusty white. That color change happens when silver reacts with oxygen, sulfur, or chlorides in the air and soil. It's not a flaw. It's evidence of metal presence. The older and more weathered the surface, the more likely it is to show these signs. But here's what most people miss. Silver doesn't only occur in veins. In some weathered regions, silver has migrated through the rock layers and formed tiny nodules or coatings near the surface. They can look like dull gray smudges until you scratch them. When rubbed or lightly chipped, these areas reveal a bright, metallic streak underneath, unmistakable and heavier than anything else around it. In rocky areas where volcanic activity once shaped the landscape, keep your eyes on the walls of eroded outcrops, stream beds, or shallow cliffs. Water and time work together, stripping softer materials away and leaving metal-rich rocks exposed. The most overlooked clues are often right at eye level, thin silver threads glistening faintly under the sun. If you see small fractures running through darker rock and tiny reflective streaks along them, it's worth taking a sample. When exploring, always carry a small hammer and a hand lens. Break a small chip off the suspicious rock and observe the inner surface. True silver-bearing ore will reveal fine metallic filaments or specks that resist crumbling. Unlike mica or pyrite, which break into flakes, silver remains solid and smears slightly when pressed or scratched. That soft smear is called a silver streak, and it's one of the oldest field tests used by miners. If you're near water, check gravel and sediments where streams have flowed through mineralized zones. Silver, being heavy, settles at the bottom of shallow bends or behind natural obstructions. In these spots, small nuggets or silver-coated pebbles can accumulate. Sometimes you'll find them coated in dark oxide or mud, but beneath that, they reveal the same unmistakable metallic gleam. Nature has another secret. Where silver exists, other precious minerals often coexist. The same hydrothermal systems that form silver veins can also create pockets containing quartz, chalcopyrite, or even gold. The key is to look for diversity in the rocks, different colors, textures, and hardness. If you notice quartz veins with metallic inclusions or spots that glitter steadily rather than flash, you're standing on valuable ground. But silver isn't always pure. In many cases, it binds with lead, zinc, or copper, which means you may first discover it through these companion minerals. Galena, for instance, often looks like a shiny cube with mirror-like faces. It's heavy and metallic. Break one open and check its texture. Some galena veins carry fine silver particles hidden within their structure. Chalcopyrite, on the other hand, has a golden yellow tone but oxidizes into iridescent colors over time. Its presence also hints that silver could be nearby, formed in the same geological system. One of the best clues is the sound of the rock itself. When struck lightly, silver-rich ore produces a denser, ringing tone, compared to the dull thud of ordinary stones. Experienced rockhounds recognize this by ear, the way the metal content subtly changes how sound travels through the material. The most promising places are often at the intersection of fractures, where mineral-bearing fluids had multiple entry points. These natural cracks act as mineral highways. Silver particles travel through them and crystallize in open spaces. Follow the lines. Look for intersecting veins, color contrasts in uneven surfaces where softer material has weathered away, exposing metallic threads. Silver's natural form is both beautiful and deceptive. It can appear as fine wires, branching filaments, or even delicate tree-like patterns embedded in rock. These dendritic forms are breathtaking under magnification and incredibly rare. Everyone tells a geological story millions of years in the making. Even small fragments can be valuable. Unlike other metals that require heavy refining, native silver can be cleaned and shaped with minimal processing. That's why it's so sought after. It's both a scientific wonder and an investment-grade metal straight from the earth. But finding silver requires patience. Many who search give up too early, mistaking dull oxidation for worthlessness. Yet beneath that rough outer skin lies the same element that shaped ancient economies, powered early industries, and continues to hold intrinsic value today. You don't need an expensive gemstone detector to find nature's hidden treasures, because nature itself already left behind clues. Clear physical signs that tell you where gemstones lie buried, waiting to be uncovered. These clues are older than technology, older than maps. They're written in rock veins, mineral changes, soil color, and the texture beneath your feet. If you can read them, you can find gemstones, even without a single tool. Every gemstone starts with a transformation, heat, pressure, and mineral fluids deep underground. When these forces meet, they create fractures, cracks, and veins, pathways through which mineral-rich fluids flow. Over millions of years, those veins harden and crystallize into gemstones. So when you're out searching, look first for veins, lines or streaks running across the host rock. They can appear white, gray, greenish, or sometimes metallic, depending on what minerals filled them. These veins often cut through ordinary rocks at odd angles. And that's your first sign. A single thin vein could lead to a pocket filled with crystals, sometimes invisible from the surface, but unmistakable once broken open. Gem-bearing zones often reveal themselves through sudden color changes in the soil or rock. You might walk over pale dust and then suddenly step onto reddish yellow or green-tinted ground. That color variation means chemical change, and chemical change means mineral activity. Gemstones form in hard, resistant rock. If you're searching near loose gravel or eroded hillsides, pick up the stones, the ones that feel heavier than they look. Those are worth inspecting. Why? Because heavier stones often have a higher mineral density, meaning they could carry crystal pockets inside. Tap the rock lightly against another. A dull thud often means ordinary stone, but a sharp glass-like sound could indicate crystal content inside. Even the surface texture matters. A rough, uneven, vein-filled surface often hides secrets that smooth, rounded stones never will. You don't need a metal detector to find veins. You just need patience. Look for long cracks in exposed rocks, cliffs, or dry stream beds. In nature, these cracks often fill with white quartz, calcite, or sometimes darker metallic minerals. Follow those veins carefully. They can lead to larger gem-bearing pockets. Even small surface veins can widen underground, forming vugs, hollow spaces where crystals grow freely. Breaking through one of these is like opening nature's vault. The colors inside can be unlike anything seen from the outside. And remember, gemstones often form together. If you find quartz or feldspar, stay alert. These can signal that other gemstones may lie nearby in the same host formation. Water is nature's silent prospector. Over time, it washes away lighter material and leaves behind heavier minerals. That's why you'll often find gem fragments in dry riverbeds, stream bends, or erosion channels after rainfall. Walk where the flow slows down, near bends or natural rock traps. There, heavier minerals like garnet, topaz, and tourmaline settle naturally. Even if you're far from a river, ancient water paths still exist. Look for smooth, rounded stones embedded in dirt, a clear sign that water once passed there, carrying minerals that may now rest below the surface. No detector can compete with water's precision. It does the sorting for you. While gemstones themselves aren't magnetic, their host rocks sometimes are. Carry a simple magnet. If it reacts strongly to a stone, it may mean iron or magnetite presence, which often accompanies mineralization zones. Another simple trick. Look for shimmer. Tiny metallic flecks or glints in the sunlight might look like ordinary mica or pyrite, but in gemstone areas, these reflect mineral-rich environments that encourage crystal formation. It's not about finding metal. It's about finding where the Earth's chemistry was active. Where two different rock types meet, gemstone formation often occurs. That's because hot fluids traveling through one rock react chemically when they hit another type. Walk along such boundaries and watch for veins, cracks, or mineral patches crossing between the two rock types. If the area feels geologically mixed, different colors, textures, or grain sizes, it's a promising sign. These natural intersections are where gemstone pockets love to form. Some of the richest gem-bearing rocks look completely ordinary on the outside. They may be gray, chalky, or even covered in mud. But when cracked open, vibrant crystals reveal themselves inside. To test such rocks safely, always wear goggles and gloves. Strike near any visible veins or discoloration lines, not the middle of the stone. Listen for a hollow sound or look for crystal edges where the rock splits. Many discoveries happen by breaking what everyone else walked past. That's the beauty of gemstone hunting. Patience and curiosity often reveal more than any machine could. The terrain itself tells a story. Gem-rich areas often show uneven ground, scattered boulders, and sudden rock changes. If you see angular stones mixed with fine soil, it usually means erosion from nearby crystal-bearing outcrops. Look for dry hillsides with exposed layers, places where wind and rain already peeled back the surface. These are windows into the Earth's hidden zones. And sometimes, one look beneath a loose rock can change everything. Remember, gemstone discovery isn't just luck, it's observation. Every crack, vein, and shift in texture is a message from underground.